We're going to move from human interest stories, which we cover a lot, that kind of what we call the softer side of quality, and we're going to move into this week's Tech Corner. This is a unique Tech Corner for us. It's the first time we're having a Tech Corner in our Studio B. Now, what we've done, and you've seen many times, is that Dirk will do a Tech Corner, and he'll have what we call our gauge cam, and that'll be the camera that'll be kind of over the desk here, and we'll look at a small piece of equipment. Well, this week's Tech Corner, we have a slightly different piece of equipment that we're going to be looking at. It is from QVI. It's their new Snap dimensional measuring machine, and we're going to throw it to Dirk now and have him look at it. Take it away, Dirk.
Okay, thanks, Mike. Yes, well, we're in our new setting here, Studio B, which is 2,000 centimeters, do the math, from Studio A. And with me today is Chuck Marks. Chuck is the regional manager for optical gauging products, OGP, and he's here to show us a fairly new product from OGP called the Snap. And the Snap is a, tell me what it is again?
Digital measuring machine.
See, I want to call it a vision system, but he calls it a digital measuring machine,
right,
which is just a vision system, right?
Pretty close. A lot of the same technologies.
Okay, tell us about it.
What the digital measuring machine is a little bit different from a video machine in that we don't have any moving elements on this. So the stage doesn't move, the optics, it's not a mechanical zoom, it's all a digital zoom. Okay. We've done a couple unique things with the Snap. One is we have a large field of view, about 78 millimeters. Field of view. We also have a very deep depth of focus of about 38 millimeters. So you can have a fairly thick part in here that you're able to measure and image.
So you can measure from the top of the part to the bottom of the part up to 1.5 inches.
Right, now
it's all in focus.
Right, okay. It's all XY measurement on this, but you're able to see any of those steps at the different heights. What we did is we have a telecentric zoom system in here. We're very familiar with telecentric optics on both our comparators and our video lines, and so we've been able to take that technology that we've learned and apply it in a large format measurement system. Very shop floor ready.
So this might be, this in a sense is kind of a, well, you probably wouldn't call it this, but an optical comparator on steroids. It's a 2D measurement system, but with depth.
Right, that's correct.
Okay.
Not only one of the challenges with a comparator is the ability to image the surface, and what we'll see here with some of the lighting techniques is you're able to look down inside parts, do measurements inside parts, which you really can't do with a optical comparator.
So I understand what we're going to do is we're going to show how easy it is to program a part, and then show what it would be like for an operator to actually run a part once it's been programmed.
Once it's created,
okay.
Yeah. Well, so what we're going to do here is we're going to start with just a fairly simple stamp part, 2D type measurement, and it's very easy to do measurements. The second major feature of the Snap is the MeasureX 2D software. Now, we've been making MeasureX 3D software for a number of years. The 2D is simply an XY measurement software on that. Okay. So we could take a...
so we can get a screenshot on this? Okay, great.
Yeah. So if we want to do, for instance, just a line, we could just click and drag, and I don't have to be right on the edge. I just bring it up, and then the edge detection does all the work. As you know, with mechanical instruments, the two of us can measure them differently, right?
Different, yeah.
So what we can do here is we can we let the system do the measurement for us. So as we begin to build a little inspection, every time I make 3 clicks, and see here it makes a circle, gives us a diameter, and as soon as I say OK, that saves that particular step in the program.
In picking up a radius?
Yeah, sure. Pick up a radius. We just click it. Notice it'll say that we're going to start with a circle or an arc, take the 3 points, and it'll go ahead and do the measurements. Now, one of the benefits of this, now we talked there's not a mechanical zoom, but there is a digital zoom. So if I have smaller features, like maybe the straight lines on the top of this these slots over here, I can move up. We have an 8-position zoom, digital zoom built in.
So you're just zooming into the part.
That's correct.
Okay.
And I can drive around the stage. All right. Even though the stage isn't moving, very similar to if you're familiar with using a video machine.
Sure.
You can drive around inside the camera array essentially, and so we can begin doing these. Continuing our programs, measuring some lines, doing whatever widths and measurements we have to do.
Does it measure angles as well?
Yep, I could construct an intersection between those 2 lines, get the the angle between them.
Okay.
Sure. From here, I can go ahead and just run the program. We'll go ahead and run it here, and you'll see it's very, very quick. There's no moving elements. So we took, I think there's about, I don't know, 8 or 9 features in there, and it measured them in about 3 seconds.
Okay.
So it's much quicker than a standard video based system would be. Or a comparator, which only takes 1 data point at a time.
It looked like the programming was, I mean, it looked like somebody could be taught to program this actually fairly quickly, it looks
yeah,
like.
typically 1 day of training for this type of system. Video systems with moving stages are typically about a 2-day training class.
All right.
Yeah. Now, one of the things we've done to highlight is when we get into a little more prismatic parts, okay, we have a adjustable stage that can go up and down up to 4 inches. So if you have a part that's got some features on one end of it, it's not very flat, we can drop the stage, we can raise the stage to make sure we're able to bring those features in focus.
Okay. Now I noticed that this part you put on there, just so people know, that part looks maybe half an inch, 13 millimeters or so in height.
Yeah,
and so that entire part will be in focus from top to bottom.
That's correct. Okay. That's correct. Some of the features we have, the lighting. As you look on the screen here, you can see that we have a backlight, so it looks very much like the comparator you
sure.
mentioned. We also have a direct surface illumination. Direct surface illumination lets us see down inside the part. Looks pretty good, but we have another set of lighting that actually will really make the internal features kind of pop, and that's our ring light. So we bring in our ring light in here. We can control the different sections of it and the different angles as we bring these lights up. Get them all going here. And so here what I've done is I've only turned on 2 sections of the light. As we rotate this around, okay, you'll see how the image on the screen there changes. Now what happens there is when we look at a CAD model, the edges are always nice and square. And then as we know as manufacturers, that's not always the case. When the part comes out of the mold or off the machine, there's going to be break edges. It's very important with a video system that we're not measuring the part, we're measuring the image of the part. So we have to present the most crisp image we can to the camera array to do the measurement.
And so I know on this ring light here, so you got 8 segments. You can select which segments you want on.
Absolutely.
And that gets programmed into gets set into the program as well.
Right. Okay. That's all part of the method there.
Now I notice looks like the ring light. Looking at the reflection here, looks like you got 2 different colors, red and green.
That's correct. We have what you can do is every other section is a different color, so you can turn on all the green or all the red. Now that may come into play if you have different color plastics. Sometimes certain lights illuminate better. We also did it for a lot of the circuit board, the PCB type applications. It also will illuminate the gold trace or maybe some of the wiring traces a little better depending on what color you have.
So you just pick which color you want.
Right.
And you do that from the setting here as well.
That's correct. All right. That's correct. So one of the things we really wanted to highlight with this system is simply an ease of use type environment. So because you have very little experience on here, so we're going to take this part we have and we're just going to put it on the stage, and then we're going to show you how you can open a program and run it without really having to know how to use the software very much. So I'll let even a magazine editor load the part on here.
Even an editor.
Yeah.
Even an editor can do it.
Yeah.
Okay, so I just dropped this. I just make sure it's roughly in the center of the screen.
That's correct. Roughly in the center.
Press this button.
Well, let me go ahead and we're going to open the program. Now, what we've done for a lot of customers is we'll go ahead and we'll incorporate a barcode scanner. And then you could walk up with your parts, you have your tray of parts, you have your traveler with it. Your traveler probably has a barcode or an RFID or something like that. You're able to scan that, you're able to get it to open the program for you. And now on the front panel right here, we have a run and an OK button. So if you want to press the run button there, and so it came up, says you're ready, you go ahead and say OK. And now what the system's going to do, I got to press it down there a little bit.
There we go.
So the system went in, and it's going through and it's doing all these measurements, and there's about 85 different individual steps that are being measured on this program. And you can see the entire runtime was about 10 seconds.
Okay.
So it's very fast because we don't have any moving elements.
Now, I noticed on this slide, is this actually a CAD model of the of what we're measuring, or is this what's actually being measured?
Right. This is a graphical representation of what we've measured. Now you'll notice we do have the flyouts showing the different dimensions, the different sizes. We can incorporate CAD. We can fit the data points over to a CAD model and do GD&T type profiles and true position and complex true position callouts.
And you would just export out of here into.
That's correct.
Okay.
That's correct.
Okay. Great. Tell me again. This took about this. How many steps did this have, or how many features did we measure?
This measured, I think, 81 different items.
It took like 10
about
seconds.
10 seconds.
Okay. Yeah. Right. And I think you said in this case we pulled the measurement routine down from a file. You're saying it could be done with a RFID scanner or a barcode scanner, or whatever.
That's correct.
Bring it in. Okay.
Yep.
What's the accuracy?
Accuracy on this is at low mag, we're at 10 microns. At high mag, we're at 5 microns accuracy.
Okay.
Yep.
What about the market? I mean, who is this primarily intended for?
You know, it's really, there's a benefit of QVI as a whole is we're really not segmented into any one market. So we do a lot of work in the medical device industry. We do a lot of plastic injection molding, government labs, you know, aerospace, military, all sorts of different markets. So really what it's designed for is customers with, you know, fairly small parts, you know, under 3 inches, with a lot of features in them that can be seen in one pass and very quickly.
Okay. Now, you mentioned that the depth of focus is, I think you said about 37 millimeters?
Yep.
Okay. It's about 1.5 inches. So if you had a larger part, you could just focus on whatever area of interest on that, as long as it fit within the volume of the machine.
That's
right?
correct.
And
we have a adjustable Z down here, so we could just raise or lower the stage up and down until we get to that area in focus.
Okay. All right.
Yep.
Terrific. Where are these available? Where are they made first?
Okay. Quality Vision International is a recently ISO 9001 certified company, and we're headquartered in Rochester, New York. And you can look for these systems with any of either the RAM optical distributors as well as any of the optical gauging products representatives. If you want to find out more information, I think there'll be a link on the flyby here that.
Right, there is actually, I think there's a link on the screen. There's also a link to the Snap product in particular underneath our player at the very bottom. Where are these manufactured?
Rochester, New York.
Oh, the manufactured? Okay.
Yes, sir.
American made.
All made in America. Yep.
Okay. Well, Chuck, thanks a lot for showing us the QVI Snap. If you have more questions on this product, you can email us questions. Actually, let me just make sure we didn't get any questions while this was coming in. If you have any further questions on this, you can email them to us. We'll forward them on to Chuck, or you can go to the link at the bottom of the page there. Underneath the player, the last link under the player is a link out to the Snap product. So, Chuck, once again, thanks for joining us here at Tech Corner. Excuse me. Mike, back to you.
Thank you, Dirk, and of course thanks Chuck, and thanks to the good people at QVI for allowing us to feature the Snap on this special episode of Tech Corner, on that special segment of Tech Corner here on Quality Digest Live. Always interesting to chat about good products, good techniques, and ways to improve quality. And Dirk, thank you for doing that.
Yeah,
that was fun.
It's kind of fun, and we've always had.